got no roots, but my home was never on the ground. I've got no roots, but my home was never on the ground. I've got no roots. I've got no roots.
In this project, we will talk about definition, applications in real life, conditional statement, inverse, converse, and contrapositive, example and truth table, and conclusion. First, I will explain about the definition of logical equivalent. When two propositions are true in the same situation and untrue in the same situation, they are said to be logically equivalent. For an example, two statements P and Q are said to be logically equivalent, and we write P by conditional Q when the statement P is true, respectively false, if and only if the statement Q is true, respectively false.
Did you ever wonder what is the importance of logical equivalence in real life? In this section of the video, I will talk about the application of logical equivalence in real life. First and foremost, logical equivalence is used in computer programming and software development. Logical equivalence plays a crucial role in computer programming by simplifying code, which improves overall efficiency and reduces processing time. It allows developers to optimize algorithms, ensuring better performance and faster execution. By applying logically equivalent expressions, programmers can minimize logical errors, leading to more reliable and error-free software applications. This contributes to creating streamlined, effective programs that perform tasks accurately and consistently. Secondly, logical equivalence also applied to mathematics and science. In mathematics and science, logical equivalence helps solve problems by simplifying complex logical expressions, making calculations more manageable. It is essential for proving theorems, as using logically equivalent statements allows mathematicians to demonstrate the truth of propositions in different forms. Additionally, logical equivalence optimizes intricate formulas and lengthy calculations, ensuring that scientific and mathematical work is both precise and efficient. And lastly, did you know that business decision-making and data analysis also uses the logical equivalence? Logical equivalence is valuable in business as it aids in making sound decisions through logical analysis of data and information. By simplifying complex data, businesses can identify hidden patterns that may not be immediately obvious, allowing for better strategic planning. Logical principles also help predict market trends and assess risks, ensuring businesses can make informed decisions that drive growth and improve overall performance.
In order to make you guys more understanding about conditional statement, I will share with you guys 3 examples of conditional statements, because I do believe that some of you might be wondering how the conditional statements looks like. So here is the first example. If you go out without sunscreen, then you will get a sunburn. Second, if it rains, then the grass will be wet. Third, if an animal is a cat, then it has 4 paws. Next, I will share with you guys the 3 statements, which is inverse, converse, and contrapositive. So how to know whether it is converse, inverse, or contrapositive? So today I will share with you guys how to know it. So first, how to know the inverse. The negation from conditional statement in both hypothesis and conclusion are negate. For example, if P then Q, then the inverse will be if not P, then not Q. Next, how to know whether it is converse. So by changing the order of hypothesis and conclusion from the conditional statement, we can know that it is a converse. For example, if P then Q, then the converse is if Q then P. Lastly, how to know whether it is contrapositive. So a statement that both swaps the hypothesis and the conclusion from conditional statement and negates both of them. By that, we can know that is a contrapositive. So, for example, If P, then Q. Then the contrapositive is if not Q, then not P.
Next, I would show a few example and truth table from the subtopic logically equivalence. As we can see from the slideshow, the first example is express in words the inverse, converse, and contrapositive of the statement below. The statement is, if Ahmad wake up early, then he will go for a morning run. This indicates the if P, then Q. Thus, we can take it as P equals to Ahmad wake up early and Q equals to he will go for a run. For inverse, we can take it as if not P, then not Q. Thus, the inverse is if Ahmad does not wake up early, then he will not go for a morning walk. Next, for converse is if Q, then P. Thus, it will be if Ahmad goes for a morning walk, then he will wake up early. For contrapositive is equals to if not Q, then not P. Thus, it will be if Ahmad does not go for a morning run, then he will not wake up early. Next, I will show the truth table from the statement below. As we can see from the truth table, we can see that the conditional is logically equivalent with the contrapositive of the argument. It is the same as inverse is logically equivalent with the converse. The next one is example 2. Example 2 asks us to prove that not bracket P and Q and not P or not Q are logically equivalent. I already provide us with a truth table that shows the value of P, Q, not P, not Q, P and Q, not bracket P and Q, and not P or not Q. From the table, we can observe that the truth value for the column not bracket P and Q and not P or not Q are identical. So, we can conclude that not bracket P and Q and not P or not Q are logically equivalent. And lastly, for example 3. Example 3 given P or Q. Construct a truth table for the statement and logically equivalent statement for each of the statement. This question asks us to provide a truth table to show which one is logically equivalent. Thus, I already provide us with a truth table that shows P, Q, not P, P or Q, not bracket P or Q, conditional, inverse, converse, and contrapositive of the statement. From the truth table value, we can see that the conditional and the contrapositive is logically equivalent with each other because each column has the same value with each other. The next one is the inverse and converse, which is logically equivalent with each other because they have the same truth value. Therefore, the conditional is logically equivalent to the contrapositive and the inverse is logically equivalent to the converse.
To conclude, in logical equivalence, we will be able to construct the truth table and determine either the argument is logically equivalent or not. Second, through logical equivalence, we can determine the statement is conditional, inverse, converse, or contrapositive. And last, through this project, we figured that logical equivalence can be applied in our daily life.